is an injector, and we're just going to talk briefly through some of the vocabulary and physics behind how this injector functions. First thing I'd like to highlight is the terminology that we use for the water that flows through the body of the injector. This is the motive flow. The injector inlet is what we call the inlet of the motive flow, and the injector outlet is the outlet of the motive flow. Although this suction port here is technically an inlet, it does draw in additive, we don't refer to it as an inlet in our literature. We refer to it specifically as a suction port. So just keep that in mind as we go through and look at the terminology that you'll see throughout the presentation and on the injector selector tool. So again, this is a lot of text. You could read through this. What I'd like to do is go back to this picture here to demonstrate how an injector actually works. So what you'll notice is as the water flow comes in through the injector inlet, you can see on the picture of the injector here, there is a constricting cone. What happens is the volume of water that's traveling into the inlet must constrict through the throat of the injector. That causes the water to speed up, and that increased velocity causes there to be a decreased pressure in the throat of the injector here. And then as the water continues on out the injector outlet cone, it expands again, slows back down, and continues on to the delivery system wherever this treated water that contains the additive is going on to. What we know about the physics that are going on here, at the inlet we have pressure energy. That pressure is pushing the water through the body of the injector. That pressure energy is converted to kinetic energy in the form of motion here in the throat of the injector. That's what initiates and causes the suction to occur. And then that kinetic energy, whatever is not used up for suction purposes, is then translated back to pressure energy. So there's a relationship here. So what you'll notice is in order for suction to occur, the pressure energy, or the pressure that you read on a pressure gauge, for example, at the inlet, must be greater than the pressure that you would read if you put a pressure gauge near the outlet of the injector. That pressure differential is required to initiate suction in the suction port, to allow us to have enough kinetic energy here to initiate that suction. And the amount of pressure differential that is required is related to how much suction you want, but in general, our injectors will start suction somewhere between 15 and 20% differential. And as we're going through this talk, ask questions in the chat window, and when we get to natural place where we can answer these questions, Gary, just go ahead and interrupt us if there are questions that come in, let us know and we can address those. So again, this is the text, the verbiage on how the Mazzei injector works. We just went through it on the picture. In order to decide which injector will function in your system, it is important to be able to gather some information. So what you'll notice in the little picture on the right is that there are many sizes of injectors. They come everywhere from 1/2 inch to 4 inch is the typical sizes that are used in the agricultural industry. In order to decide which of these models will fit best in the system, which is really what our focus is today, you need to be able to gather some information. And again, one of the things that we said we were going to go over is the automated injector selector tool. This injector selector tool will walk you through these steps. But before we get to the automated tool, I want to give you a little bit of information on what you'll need to know when you arrive at that tool. So the first piece of information you'll need is right here, the information about what is being injected. What do you want to inject? Are you injecting a liquid, a gas? What kind of liquid? Is it very viscous? Is it very heavy? Is it caustic? Is it an acid? All of those pieces of information are important to know which injector is the best for your system. Also, how much do you want to inject? What's your injection rate? The next piece of information you'll need is the motive flow rate. Again, remember the motive flow rate is the rate at which the water flows through the body of the injector. Just to reiterate, the injector does require a certain flow rate at a certain pressure. So it is important that whichever injector is chosen, that the amount of water available in the system is greater than or equal to the amount of water that the injector requires. So you don't want an injector that needs more water than you've got available to give. The next piece of information is the pressures. So the injector inlet pressure, what's the pressure upstream of the injector, and the injector outlet pressure. What will the pressure be downstream of the injector once it's installed? Here are some terms. Again, this is really for your reference in the download version. Let me just highlight a couple of things. We talked briefly about pressure energy and kinetic energy, and these two principles down here, physics principles, down here, the Venturi effect and Bernoulli's effect, that's what we were describing and how the injector functions. Also notice that there are different terms that we can use for PSI. There's PSI-A, or absolute pressure, or PSI-G, or gauge pressure. This is what we will be referring to today, PSI-G. That is the pressure that you would see on a gauge if you put it on your system. And that's what our performance tables and our injector selector tool refer to. So we define inlet pressure. The pressure at the inlet of the injector is what we call the inlet pressure, pretty straightforward. The inlet pressure is what determines the water flow through the injector, or the motive flow. Those are directly proportional. So as your inlet pressure goes up, your motive flow goes up. The amount of water that passes through the injector is directly proportional to that pressure at the inlet of the injector. The outlet pressure. This is the pressure at the outlet of the injector, downstream of the injector. This is a function of whatever is downstream of the injector. So if you must pass this volume of water through a sprinkler delivery system that requires a 50 psi pressure, then the injector will see that 50 psi as its back pressure. If you're delivering this to a drip system that requires 10 psi at the head of the drip system, then that 10 psi the injector will see as its back pressure, in addition to any other components that are between the injector and your delivery system. Again, just to reiterate, water flow is a function of inlet pressure. So as inlet pressure goes up, so does the water flow. Brief tutorial on our performance tables. If you haven't seen them before, they are available on the Mazzei.net website, and these give you, you can print them out. They're in PDF form. You can view them on your smart device or anything else if you're on the go, but they are easy to read once you know what you're looking at. So let me just highlight this. The injector inlet pressure here, the column, the leftmost column, is measured in PSIG. If you travel down that column, you'll see options for injector inlet pressure. We've highlighted the pressure of 15 PSI, and then you'll notice the third column over is the motive flow column, and at 15 PSIG, this particular injector, the model 1078, has a motive flow of 9.5 gallons per minute. How fluid suction occurs. Again, we've talked through this, so let's look at a visual. As you have a pressure differential, you will create a vacuum space here in the throat of the injector that will initiate suction through the suction port. The greater the pressure differential, the greater the suction capacity. You can see that in this example here. The example on the left demonstrates a high suction case where you have 25 psi or 5 psi outlet pressure as an example. That is a greater pressure differential than the case on the right, which is a low suction case. 25 psi inlet pressure and 20 psi outlet pressure. Notice that the amount of vacuum space available to draw in the fluid is greater when you have greater pressure differential and less when you have lower pressure differential. Now, the pressure differential, as pressure differential increases, so does your suction capacity. There is a point, though, where you reach a maximum suction capacity. So no matter how much more pressure differential you give the injector, if it has reached its maximum suction capacity, it's reached its maximum suction capacity. And you will notice that on the injector performance tables at about 50% or so pressure differential on average, you'll see that even if you allow more pressure differential, you're really not gaining much more suction capacity. And that's one of the key pieces of information you don't have to memorize, because that is built into the injector selector tool. It knows that anything more than a 50% differential is really not going to gain you any more suction. So it takes that into account in the back office logic, you want to call it, and it will choose the most efficient injector for you. So again, you can see on the performance tables, the greater the pressure differential, the greater the suction capacity. But what you'll notice, again, what we were talking about, is at some point you max out the suction capacity. In this case, at 25 psi injector inlet pressure, whether you have 5 psi outlet pressure or no 0 psi negligible outlet pressure, your suction capacity remains pretty constant. Then as you increase your outlet pressure, which is the second column over from the left, you'll see that your suction capacity decreases. So those are inversely proportional. The injector outlet pressure is inversely proportional to the suction capacity. At some point, you have too much back pressure or not enough pressure differential, and at that point, fluid suction ceases. That is what we call our zero suction point. And you can see that as well in the injector performance tables. You'll notice if you look at a performance table, there are these curious blue numbers here in parentheses. This is the pressure at which the injector stops functioning, the outlet pressure at which the injector stops functioning. So in this case, with an inlet pressure of 10 psi, once you get to an outlet pressure of 9 psi, you no longer have suction. Okay? So before we move on, we'd like to know a little bit about your experiences with Mazzei type injectors. How have you used these in the past, or are you familiar with them? Choice A, I have used injectors in my farming operation. B, I have designed irrigation systems with injectors. C, I have heard of injectors, but I'm unfamiliar with how they work. Or D, what's an injector? So hopefully we'll have the majority of the people in choice A through C.
Great. So a lot of people have already selected their answers, but we'll give some more time for Arturo. Oh, Arturo just answered, and Brandon and a few others are still thinking about these.
All
Maybe
right.
Jim Anschutz could. I don't. Jim's participating via mobile, so I'm not sure if he can answer. But let's see. Still JNL and John Petroso are thinking about it too. Good participation.
All right. And I'm noticing, Gary, that we do have a few questions in the chat window. Maybe we can take a moment here to answer one or two of those.
Sure. Okay. So let's take Eugene. I think Eugene's name is indicating that he's in Kenya. So hi, Eugene. He says, I want to inject acid into irrigation water to achieve a certain pH. The problem is that the downstream pressure changes due to differing water demands. How do you overcome that? Okay.
Well, yes. To give you the briefest answer, the change in the downstream pressure will affect the suction capacity. A way that you can overcome that is to put some kind of regulating device on.
Yeah, and if you have changes in the pH in the water too, as far as automating that through some sensor system, I imagine the sensor systems are incorporated in order to get that feedback. Then the sensor can regulate the suction port through some kind of a metering valve.
Mm-hmm. And we'll show an example of such regulation here in just a minute.
Great. And CC, I put up the polling results on the bottom of the slide there, if you can see them. Disregard the bottom one. That just means that's just a systemic issue and not people who are participating.
Okay, very good. All right, so it looks like the majority of the people here are in category B. We have a range, so that's very good. All right, thank you very much for your feedback. That helps.
Still have some people that have heard of injectors but aren't quite familiar with how they work, so that's good to know too.
Mm-hmm.
Thanks, everybody.
All right, thanks very much. All right, so just as a reminder, the relationship between flows and pressures, the mode of flow is a function of the inlet pressure. It does not change significantly as your outlet pressure changes. The injector suction capacity, however, is a function of that pressure differential. So as your downstream pressure changes, your suction capacity will change. Some other factors that affect the liquid injection heat are things like the specific gravity of the material that you're injecting. If you're injecting something that's much heavier than water, for example, you will have a decreased suction capacity, and we can take that into account very easily with a quick calculation. There's a technical bulletin 1 that we have on the Mazzei.net website that is free. It's available for anyone to look at. There are some very quick multipliers that you can use to correct for these common issues that you see in liquid injection. Another factor would be if there is a pressure or vacuum on the suction port, and that could potentially be in the form of the location of the liquid with relationship to the location of the injector. So let's say the liquid is in a tank that is 5 feet above where the injector is physically. That would put added pressure on the suction port and increase the suction capacity of the injector. Let's say the additive is below the level of where the injector is located physically. That would impose a vacuum on the suction port, which would require the injector to lift that material before drawing it in, which would decrease the effective suction capacity, and there's a correction factor for that in there. Also, please note if you are not located at sea level, if you're on the top of a mountain using an injector, then you will feel the effects of the atmospheric conditions being different than at sea level. Your atmospheric pressure is lower if you are in Denver than, say, if you are in Malibu Beach. So if you're trying to use an injector in a different location other than sea level, you need to be aware that at higher elevations, you do have a slight decrease in the suction capacity. Remember the way the injector functions, it creates a low pressure area in the throat of the injector. That essentially allows the atmospheric pressure to push material into the throat of the injector, into the suction port of the injector. So if your atmospheric pressure where you live is lower than the atmospheric pressure at sea level, which is where we ran our tests for our performance tables and the data that we've gathered, then you will see a different suction capacity. This section will talk through some of the typical installations that you see. Each of these typical installations that you see in the world can be distilled down into one of these 3 categories. Either you have the injector on a bypass and your reducing the pressure. So now the injector sees a pressure reduction due to a pressure reducing valve or device that you have in your system. Or you're not reducing your pressure, but you have a booster pump that is feeding the injector, not the suction port of the injector, but the injector motive inlet side. Or you have a full flow method, which means that the entirety of the water flow is going through the body of the injector. So the flow of your whole system is the whole motive flow of the injector. The full flow method is not as widely used in the agriculture industry, so we will not be going into great detail. That is it requires some precise design to get a full flow method to function properly with a system. Another reason why it's just not practical to go into detail right now. Just a note of caution, the injector outlet must be flooded. In other words, you cannot install the injector with a no back pressure situation. Here are 3 bullet points that give examples of no back pressure situations that we do not want to do. If the injector does not have piping attached to its outlet, it's an unlikely situation, but if you ever see that, that is a no-no. You will not have suction in that case. The injector being installed vertically is not a problem if it's installed vertically pointing upward, but if it's installed vertically pointing downward, you may lose suction. And finally, if the injector is installed somewhere where the outlet is connected to a vacuum tank or some sort of anything that would cause the injector outlet to have no downstream pressure, these are all situations where you would want to be cautious and avoid them. So the pressure reducing method looks something like this. This is probably familiar to you. Let me highlight a few things on here. So you have your pressure regulator here. Notice that the upstream side of the pressure regulator on the left-hand side here reads a higher pressure than the downstream side of the pressure regulator. This is a natural place where you can install a Venturi type injector on a bypass around this already existing pressure drop. The injector being installed in parallel with this pressure regulator will see at its inlet the same pressure that the pressure regulator sees upstream, and the injector's outlet will see the outlet pressure that the pressure regulator sees. So another thing that we want to highlight here is the metering capabilities. So one of the questions was with regard to changing downstream pressure. You can adjust your suction with an optional metering valve or flow meter. These can be simple or complex, fine-tuned or very coarse. Whatever meets the needs of your system, you can use. Let me highlight another piece of information here. This piping that is connecting the injector to the main line, if this is, for example, a 2-inch injector, then this should be at least 2-inch piping. You don't want to have piping connecting to the injector that is smaller than the connection size of the injector itself. And the same thing goes for the suction tubing. If you can connect it up to the injector and you're not reducing it from what the injector's hose barb is naturally here, then you're in good shape. Notice though that if you have a long run of suction tubing, that you will have resistance to flow in that line, and that could impede your maximum suction capacity. So just be cautious of that. Also, if you have something that's very viscous, then you may want to step up your suction line tubing so that the viscosity of the material does not hinder the suction capacity as much. So this is an automated type of system where you have an automatic pressure regulator in place. This could also be done manually. You could have a manual valve here. It serves the same function. You just close that valve down until you initiate suction. Remember, suction is initiated when you have sufficient pressure differential between the inlet and outlet of the injector.
So this is an example of what you don't want to see in an application in the field. This pipe is probably 12 inches in diameter and supplying 800 to 1,000 gallons a minute, and it is installed with 1-inch fittings for a 1-inch injector. In order for that injector to pull in the desired amount of material, the differential that needs to be created, it will be quite high, and you'll lose a lot of pressure in the process. So our recommendation is put the size valves that will accommodate the larger injectors to be able to utilize a lower differential to activate the injector. This should have probably 3-inch entry ports, so a 3-inch injector will operate to obtain the desired suction capacity.
And that's something, again, that we take into account on our injector selector tool. The tool will choose, in a pressure reducing method, the tool will choose the largest injector that satisfies the need in order to minimize the pressure loss across your pressure reducing valve. The injector may be on the bypass, the injector may be in the main line. This is just an example of that. If you have a large motive flow as compared to the amount of water that you are bypassing around the injector, then it might be to your advantage to put the injector in the main line and make your bypass system the part that has the pressure reducing valve. And then again, it would function the same way. You just close that pressure reducing valve down until you initiate suction, until you have sufficient pressure differential to initiate suction. And because the injector and the pressure reducing device are in parallel, they see the same pressures at their inlet and outlet. You can do this with multiple injectors. Same principle applies. Close the valve down until you have sufficient pressure differential. Both of those injectors will see the same pressure differential and will initiate suction. The booster pump method. This is helpful when you do not have you cannot afford a pressure loss in your main line. You don't have the capability to reduce your pressure. So what we do here is we take a small portion of the main flow, boost the pressure of that water, and provide that to the inlet of the injector. So now the inlet of the injector sees the higher pressure water from the booster pump, and the outlet of the injector will see the main line pressure. Now in this case, it is most advantageous to choose the smallest injector that will give you the suction capacity that you need. You want to minimize the horsepower that you use in this booster pump here.
One thing I might add, that utilizing Venturi type injectors for putting additives into the irrigation system allows you to have a continuous feed. At the same time, you'll have a thoroughly mixed water fertilizer mixture going into the main line, and that's usually desirable for good distribution out in the field. And this is a typical booster pump application where you have a pretty good flow, probably 800 gallons per minute in this system, and they are using a 2-inch injector which has the capacity of pulling in 10 gallons a minute. And that's the setup. As you can see, the inlet to the pump is upstream from the supply line, and it continues through the pump, through the injector, and re-injects into the main line. Again, this is a good example of continuous, well-mixed fertilization into the main line.
Again, this is just an example of the full flow method, but we will not go into great detail. Just remember that the injector itself is being used here as the pressure and flow regulation. So the upstream side of the injector will see a higher pressure than the downstream side of the injector. The injector itself is acting as the regulator here. So now that you have an understanding of the way that the injector works and the kinds of installations that it can be put into, we'll go through some examples on our injector selector tool. First, I'd like to caution you that this tool is for liquid injection only. It is not for gas injection, although our injectors are commonly used for gas injection. This tool is specifically designed for liquid injection applications. In order to use the tool, you do need to register. It's free, but you do need to register. We want to be able to contact you if there are any updates. And also be aware that there is security on this tool, so we don't allow the same person to be logged in or the same login to be used at the same time from different locations. So it's always important that you log out when you're not in use. If you just close your browser, the tool will assume that you are still logged in. So you need to be aware of that and make sure you log out when you're not using it so that when you log in again, our security doesn't give you a red flag. And this can be accessed through the Mazzei.net website or the Toro.com website. And at this time, I'll go live to our, show you my desktop here so we can get on the internet. Okay, so at this time, you guys are seeing the front page of the Injector Selector tool. This is accessible from the Mazzei.net website. There is a button on the left-hand side that says Injector Selector. Or it is accessible from the Toro website. Let me go to toro.com/agriculture.
And Cece, while you do that, let me let everybody know about something. In the upper left-hand corner, right over the Toro logo up there, you'll see a little option there that says Scale to Fit. If that isn't checked, go ahead and check it on your computer. For most people, it should be checked by default, but just in case not, go ahead and put a check mark there, and it will help you have a better view.
Thanks, Gary. And Gary, also, if there are any questions or things that come up in the chat window here, since we can't view that in this view, just let us know.
Of course. Actually, if you, I'm sorry, I'm getting a little conflicting advice here. If you uncheck it, it'll load fast. You want to uncheck Scale to Fit. If that helped you have a better experience, do that. Sorry, Susie.
No problem. All right, so from the Toro website, on the left-hand side here, you can see the injectors link. Click on Chemical Injector. And then scrolling down, there's some information about chemical injection on the small graphic here. So if we click there, and from this page, you can arrive at the Chemical Injector Selector tool. Now, if you are a new user to this tool, you will, again, need to register. Just a bit of contact information that we need from you, and then click the Save button. And this is not an automated process. We actually look at each person who applies to use the tool, and we approve you. A human actually looks at your record and says, yes, we approve you, and sends an email to you. And then once you have been approved, you can log in as an existing user. So I'll go ahead and log in. And let me just walk you through what you see on this dashboard here. And then I'll hand it over to Angelo to walk you through some examples so you can see how the tool functions. So on the left-hand side, you'll see there are 3 buttons. The top one says Start a New Session. That's probably the most common one you'll be using. The next one down is available for you to update your user profile. And the last one is the logout button. Again, please make sure that you log out when you get out of the tool so that you can log back in without incident the next time. So on this dashboard page, you'll notice that I've run several different sessions. And each time you run a new session, it will save it to your history here. You can narrow them down by date. You can choose a session by clicking the radio button next to it, and then you can revisit that session by editing it, viewing the recommendations or the summary, or you can start a new session already populated with this session's data, but it would be a separate session, saved as a separate session for you. So there are lots of options here. So what we'll do right now is start a new session, and you'll see that there are 3 choices. Again, these are the 3 main groups of typical installations that we talked through, either a booster pump method, a pressure reduction method, or a full flow method.
Okay, and so what we'll do here, we'll select a typical application for a pressure reduction and a typical application, or more than one typical application, for the pressure boost system. The pressure reduction method is mostly used in drip irrigation because of the operating pressures are generally low, generally less than 30 psi. So let's see. There we go. So as you can see, this kind of self-guidance across the top of the screen, you can refer back and change things as you're populating it. But there's total flow. Of course, you want to put the project name so you have some kind of a recording and a reference. So you have total flow, suction capacity, elevation, additive weight of the product that you're injecting, the injector location, upstream pressure, downstream pressure, and the pressure regulator. All of those were discussed previously. So let's select I'm going to select a small farming operation irrigation system. So a typical small farming operation, I'm going to say somewhere around 35 gallons per minute. And what is the suction capacity needed? We'll put in 10 gallons per hour. What is your elevation? We'll just use sea level for right now. And what is the weight of the liquid additive? Fertilizers range generally above, of course, the weight of water of 8.34 pounds, as is indicated here. And so I'm going to put 10.5 as a fertilizer combination. And will the injector be located above or at the level I will use it for this demonstration? We'll use the same level. So the next question is, what is the upstream pressure? A typical irrigation system for drip irrigation, they're going to have anywhere between 20 and 30 psi available, many times less, but let's go ahead and put the 30 in there. And the downstream pressure, well, I have a pressure reducing device and I know the downstream pressure, or I do not know the downstream pressure. Under this situation, we'll go ahead and we know what the downstream pressure is. The drip irrigation tape is going to be, at the head is going to be at 10 psi. And will this be a manual operating a valve or an automatic, we'll go ahead and use the automatic. And generally, on pressure regulating devices, there needs to be a certain amount of flow through that device in order for it to function. At 30 psi, I will just indicate it needs a minimum of 10 GPM to go through that valve. And so here is what gets populated. We have the choice of a 1-inch injector, and as you can see from the bottom to the top, we know what the downstream pressure is, 10 psi. The water flow through the injector is 24. That is enough to be able to allow the pressure regulator to function because it needs an additional 10 GPM through the pressure regulator, and that's less than 35. So the injector inlet pressure is 30. 24, 13. The water flow through the injector with the 1078 is 13 GPM. All of these, you take a look at this, is 190 gallons per minute of suction capacity, way over what we have requested. So the injector that will fit nicely under this would be probably an 878 because it will have a suction capacity of 61 gallons per minute. It gives you this choice so you have at least a choice of what's available, what you have in stock or whatever. And it doesn't require any more energy to operate any one of these. So you have this choice available. Now let's make some changes here. The nice thing of this program is you can change the requirements. Say that the motor flow is not 35 gallons a minute. Let's say it is only 20 gallons a minute. You just slide this back, and you can see the injector selection immediately changes due to the flow rate, the flow available through the injector. As was discussed earlier, you have to have a certain requirement through the injector for it to function. So let's take a look at the upstream pressure. Let's say that we only have 20 pounds of pressure available, not 30 pounds. So you can slide this bar, and it's very convenient as to, on the fly, make adjustments and see the variations that these adjustments cause. So now the selection of injectors, you're good with this 10 pounds, but let's say that the system is at the bottom of the hill. So you have to push up a ways, so your pressure is going to be higher at where the injector is. And there are the selections under those conditions. The suction GPM, again, you're looking at a GPH, I'm sorry. The suction is rated in GPH and not GPM. So let's say you needed to have a little more. Now, you eliminated all the possibilities except one, just because of that. So this is an example of the flexibility that selecting an injector has.
Okay, now let me highlight for you. Once you have a compilation of recommendations here, then what you'll notice is you have the ability to, on the right-hand side here, save this session because, of course, we have changed a lot of the inputs that we originally gave the system. So if we'd like, this example project that we have saved here, we can save with these new inputs, and that session will be updated. You can also view the summary here, which is the next tab up at the top. The recommendations page was where we were before, and the summary tab right next to it. Shows you on the left-hand side the information that we now have saved under this project. We have the project title. We have what method we're using. This is the pressure reduction method. We have the flow rate, the suction capacity required, the additive information, where it's located above or below the injector, pressures upstream and downstream, and information about the pressure regulator. You can take this and send it to someone. Let's say you're a dealer, you want to send it to the customer that you're designing this irrigation system for. You can say, "Hi Joe, this is the best injector for your system. Thanks. Oops. And it would be helpful if I could spell thanks right. All right. And what you can do is you can send this over on the right-hand side. You can send the PDF report. And you can choose a recipient. So let's say I wanted to send it to my friend Joe at farm.com. And I can also copy myself. You can also click the box over here that sends a copy to us here at Mazzei Injector if you, say, are working with one of our system designers or one of our engineers and you want to copy us on it and say, "Hey, I sent you a copy of this. Does everything look right? I had some other questions." You can certainly populate that comment box with other questions or pieces of information that you might want us or your customer to look at, and then you can send that, and this is what it looks like down below. So the injector selector tool gives you all of this information, and it also says who it was prepared by. So if you logged on, this prepared by section would have your name in it and your contact information. So let's say you're a dealer, you can have your contact information right there on the report that you're sending over to your customer. So this is something that's helpful. And you can go back to your recommendations page. You can always edit the session, or you can go back to the dashboard and start a new session. So we'll go through just one other quick example on the booster pump method here. So we'll choose booster pump as our.
Okay, so I will go ahead and select a large farm operation for this, and we'll put 1500 GPM as the flow. And and generally the booster pumps, they are used for the drip irrigation, but they're definitely used in sprinkler irrigation, which has higher pressure. And so we're going to put 55 pounds. And the suction capacity, it ranges all over, but I will use 100 gallons per hour. Sea level is 0. And the weight of the liquid, I'm sorry. We'll put 10.5. I will just keep it at . And here are the selections. When using a booster pump, you generally want to use the smallest injector that will give you the desired suction capacity, because as you can see on this, it gives the system pressure, but it also gives you the water horsepower needed to drive the injector. So if the injector suction capacity is 100 gallons a minute. Here you have 104 gallons a minute available with this smaller injector at, with 1.22 horsepower. And so it gives you the choices, but everything's going to be predicated on energy. So we want to select the smallest amount of energy necessary to drive the injection of the fertilizer into the irrigation system.
And in the interest of time, if you have any additional questions on this, we'll certainly field them. But we want to make sure that we have given you enough information here so that you can utilize this. Again, remember, when you are finished with your sessions, and then look, you can see we have an example project here that we just did, and it's saved on our dashboard. Make sure you log out, and then you'll have the ability to log back in easily. So right now, let's get back to, in your chat window, if you wouldn't mind just typing in what the most valuable thing you've learned today. That would be helpful for us to know.
And Cece, we had some questions come in, so because of the time, I'm just going to overlap and give you some of the questions now while folks type in the chat. Is that all right with you?
That sounds great.
Great. Okay, because Casey had a great question. Is there a mobile app for this?
That's a good question. We are in the process of developing a mobile app. It is not completed yet, but it is usable on your mobile device. So we have tested the injector selector tool on BlackBerry, iPhone, and Android, and it does function. It's just not quite as pretty as in an app form.
Okay, so for beauty we have to wait a little bit longer. Excellent. So, okay, so we have a couple of questions here from folks, and I'm going to put that in. I see we have several people who have put in what some of the most valuable information they learned. And Fabio had a question. Can I see the prices of injectors? Oh, in the app, in the phone app, can you see the pricing of the injectors in it?
No, the injector selection tool is strictly informational. But contacting Toro would be the easiest way to get the pricing information.
Very good, sure. Otherwise, you'd have to constantly be updating the phone app, and there's not really a need for that otherwise. Okay, good. Here's a question for you. If there are several recommended choices using the injector selector, I don't know if that's possible. I didn't see there was. Is it better to choose the smaller or larger injector?
Okay, that's a good question.
Yeah, great question. On pressure reduction method, choose the larger one, especially when you're operating a large farm system. Let's say a pressure reduction method, and you're running 1,000 gallons a minute. You want to minimize the pressure differential needed to allow you to bring in the desired amount of fertilizer, because 1,000 gallons a minute, energy is very important, and you don't want to reduce that energy very much. So under those conditions, the largest injector is always beneficial. Under the pressure boost situation, same thing occurs. Energy is an issue, so you want to select the smallest injector in that choice and allow the pump to operate at a much lower horsepower.
And I might add that the injector selector tool does think about that for you. So when it provides the results in the list, the top result, the first one that you see in the list, is what it thinks is the most efficient for use in your system.
Great. That's a great answer and a great, actually a great system too. Okay. By the way, Eugene, I see that you have another comment in your follow-up question, so we're going to save you till last and take these other questions first. Which injector is best for agricultural chemicals such as acid and chlorine and fertilizer?
We manufacture injectors in polypropylene, and there are compatibility charts available to compare the chemical to the compatibility with polypropylene. We also make these injectors in polyvinylidene fluoride. PVDF is the acronym for it, and that is very resistant to acids. Absolutely, totally resistant. It'll handle the heat, especially when you're running sulfuric acid into water. These injectors are capable of above 212 degrees, 250 degrees.
Okay, and I see here that CC has typed in that PVDF is resistant to acids, so that's a great solution. Good. Can we take on a size question? I'll give it to you, and then you can decide. What size pipe should we use to connect, say, a 1-inch injector model 1078 to an irrigation system?
Okay, so in general, the rule of thumb is that any time you connect an injector up to piping, the motive flow piping should be at least the size of the connection of the injector. So in that example, a 1-inch injector, a model 1078, has 1-inch connections. So we would use 1-inch piping to connect that up to the system, nothing smaller. And also please be aware that if you're using any fittings or isolation valves, that those also need to have ID of that 1-inch or greater.
Oh, great. Okay, thank you. That certainly gives us a good answer to that question. One more, I think, and then about time to wrap it up here, with the exception of Eugene's questions. Is it better to plumb the injector with a manually operated valve on the main line or with an automatic pressure-reducing valve?
That's just a matter of cost. Many people use a pressure regulator valve because that's what they maintain their fields, especially when they go from one field to another and the block sizes are different and they want to maintain the same downstream pressure, so they use an automated valve. Other people will, on a smaller farm operation, they'll just use a ball valve or some kind of a restrictor valve on the main line to create the differential necessary only for the time when they want to suck the fertilizer in. So, you know, the choices are really up to the operator.
Okay, great. Well, thank you, Angelo. So, again, Eugene, we know you have a follow-up question there. I'm going to hold on your question for a moment because I would like to make sure that we thank Toro for sponsoring today's event, and to thank Angelo and Cece, of course, for making themselves available to bring their expertise on this unique and very valuable tool to us, and to thank all of you for attending today. And we'll go ahead and continue to run the recording while we tackle Eugene's question, but thought that the rest of you might like to know that you can access it if you have to go later on through the recording, and we'll notify you how you can do that tomorrow morning. So thank you all for coming, and let's go back then to Angelo. Do you have time for this to take
Absolutely.
on? Okay, great. So you made a suggestion to, and I can go back to the original question before. You had an answer for Eugene on his situation before, but he says he's tried that manually without success, and he's wondering where he can obtain an auto-regulating device that you suggested. And he says, he comments to you, what does work well that he has tried is batch injection, where a certain amount of liquid needs to be injected within a certain period of time. And I think he'd like to know if you have any comment on that as well.
That's a great question, and many times what farming operations will do is they'll absolutely batch a certain amount of liquid in a day tank, if you want to call it, and then they'll snorkel down into that tank to the level at which that would equate to the amount of material to be put in at that irrigation. So once it breaks suction, it's not pulling anything in, and pulling air does not affect or hurt anything downstream. That's the nice thing of having a pump in front of the injector. The injector will suck air, and it will just, you know, send it on down the line, and it's not that amount. It's not going to be an amount of air that's going to present a problem with the piping system.
Okay, great. So Eugene, I hope that answers your question. So Avner's advice about getting air out of your lines notwithstanding, this is not enough to really bother anything. Okay, good. Well, thank you again, Cece and Angelo, both of you very much for doing this, and thanks again to Toro and everybody at Toro, including Inge and Sky, who helped us bring this together today. We look forward to doing another session, hopefully with you, Angelo and Cece, in the future. And meanwhile, thanks again, everybody. Have a great week and a great weekend. Thanks for attending today.
Thank you.